Okay, this is 5.3 in the pre-calculus textbook that tells the cotangent of theta is 2. It's in quadrant 3. If the cotangent is 2, and I know the tangent and cotangent are reciprocals, the tangent would be 1/2. TOA, tangent, is opposite over adjacent, but in the third quadrant they're both negative. So you find your Pythagorean theorem, find your hypotenuse, which is always positive, and it should be radical 5. Now the rule for sine of 2 theta is 2 sine theta cosine theta. So we just need to fill in what sine and cosine of theta are. So let's do that right now. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now when you multiply your top times your top times your top, I believe you get a 4. Bottom times bottom times bottom should give you a 5. Now for cosine of 2 theta, there's 3 different rules. Which one would you like to use? Okay, I think these are our 3 options. So it really doesn't matter which one you'd like to use. I think somebody suggested the first one, so let's try the first one. 1 minus 2 sine squared. Well, what is sine? Sine is opposite over hypotenuse. Opposite over hypotenuse. Opposite and hypotenuse. Now, when you square a fraction, you square the top and you square the bottom. So that becomes 1 minus 2/5, or 5/5 minus 2/5, making this 3/5. Now tangent, you also have options. Some people like to just know that tangent is sine over cosine. And we just found these values from part A, 4/5, and the cosine was 3/5. So 4/5 times the reciprocal, I think, would make this one 4/3. We could have also used a formula. Okay, this is 23 from section 5.3. We'd like to try and show this identity or verify this identity. Do we know a rule for sine of 2 theta? 2 sine theta cosine theta, correct? I'm going to try and turn the top into a tangent. And what is tangent? Sine over what? Right now this is over 1. Do you agree? So how about if I multiplied 1 over cosine and 1 over cosine? I see, it looks to me like I'm trying to match the top a little bit. What would this give me? Would this give me, let me go back to what I had, 2 sine theta cosine theta over cosine theta, all divided by 1 over cosine theta. Now, what is sine over cosine? 2, right now I have 2 tangent theta times cosine theta on the top. Do you agree? And on bottom I have 1 over cosine. Let's see if I can get rid of that cosine. How would you get rid of that cosine? By multiplying by 1 over cosine? This might not be the correct approach, but we'll find out if it works. Here the cosines would cancel and I'd have 2 tangent theta. Now, right now, do I have the numerator matching what I need for the numerator? And I believe the bottom would be 1 over cosine squared. And 1 over cosine is secant, so because it's squared would be secant squared. And secant squared is the same as 1 plus tangent squared. There might have been a more direct route, but now I believe I have it matching what we're supposed to match. Again, my strategy was kind of to choose either the numerator or denominator and try to make it match what they had. Now you did have to know the identity that 1 plus tangent squared equals secant squared, because that makes this equal this. Yeah, that's a Pythagorean identity. When I see this problem, I kind of want to work on the right simply because I have identities for 2x's. Otherwise, I'd have to turn this into a 2x's. Sine of 2x I know is 2 sine x cosine x. And I know that cosine of 2x is 1 minus 2 sine squared. So that leaves me with 2 sine x cosine x on the top. On bottom, 1 minus 1 is 0, and that becomes 2 sine squared, which allows those to cancel, leaving me cosine over sine, which is cotangent. And then that would match what I needed it to match. On this one, I see the 2t is on both sides, so I don't care. We could work on the left, we could work on the right. Let's work on the left, I guess. Do I know a rule for sine of 2 theta? So it'd be 2 sine t cosine t minus tangent of t minus tangent of t. I'm not sure. Could tangent be called sine over cosine? Now, if I want a common denominator of cosine, what would I have to do to this first part? Multiply by cosine over cosine. Would that give me the right denominator? So what would I have on top here? 2 sine t cosine squared t, I believe. Let's see. Well, I need to somehow to get this. Factor a sine out is what you're saying? If I factor a sine out, that'll give me what? 2 cosine squared minus 1, right? And this is all over cosine. So that will give me a tangent here. And this right here, is that a cosine of 2t? So I think that allows us to match it. To do this one, you had to know the 3 ones for cosine of 2 theta. It could have been cosine squared minus sine squared. It could have been 1 minus 2 sine, or 1 minus 2 cosine. No, 1 minus 2 sine squared. Or it could have been 2 cosine squared minus 1. I believe that's the one that I used right here to get cosine of 2t. Okay, I was asked number 13. This one is in quadrant 3. So I may emphasize quadrant 3. I'll make my angle in quadrant 3. There's the right angle, there's theta. It says the sine is negative 9 over 41. Sine is opposite over hypotenuse. Now we have to do Pythagorean theorem to find the missing side. So let's do that in yellow. I would have legs squared plus legs squared equals hypotenuse squared. That would be plus 81. So 1681, when I subtract 81, this becomes 1600. If you take the square root of 16 as 4 and half the number of zeros, I believe this would be 40. However, in quadrant 3, I think it's also negative. Now, what's an identity for sine of 2 theta? 2 sine theta cosine theta. 2 sine cosine. Do they tell us the sign in the problem? Cosine is adjacent over hypotenuse, so that'd be negative 40 over 41. When you multiply all the tops, what do we end up with? Positive, because it's negative times negative, 18 times 40. So I filled in what the sine was, I filled in what the cosine was, and we did the arithmetic. Now we're going to use one of those formulas for cosine of 2 theta. Again, you could pretty much use any of these. Any preference? First one? Cosine squared minus sine squared. Okay, so we'll do cosine squared minus sine squared. So it's something squared minus something squared. Cosine is adjacent over hypotenuse, and sine is given. It's opposite over hypotenuse. When you square 40, you square the 4 and double the zeros, and you're going to add 81 over 1681, squaring the top and squaring the bottom. So it looks to be 1681 over 1681, or 1. Oh, it is minus. You're absolutely right. So what would you get if you subtracted here? 1519 over 1681. Hopefully that's what they have for B. And finally, for tangent, most people like to do sine over cosine, which we kind of know. Sine was 720 over 1681 divided by 1519 over 1681. 720 over 1681. How do you divide by this? Multiply by the reciprocal. Those would cancel, and what would I get? 720 over 1519. Okay, in 33, you might notice that this angle is 4t, whereas over here all the angles are simply t. So I'm going to work on the one that has the 4t. Could this be written as a double angle? Could this be written as 2 sine 2t cosine 2t? Do I know something for the sine of 2t? This right here. Does the sine of 2t become 2 sine t cosine t? Basically the same thing. I just did it again. Now what about cosine of 2t? What could that be written as? Notice I have a cosine cubed, so maybe, which ones, does any of them start with the cosine squared? Cosine squared, we do it in yellow. Cosine squared minus sine squared. And if I distribute, this is a 4, so this would give me 4 sine times cosine cubed minus 4, because I'm multiplying here also. Sine times sine cubed would, sine times sine squared would make sine cubed. And sine cubed, and you'd also have a cosine, right? Does that match what I'm looking for? Yeah, so I had to do a double angle here, and then do a replacement for cosine at 2 theta. Okay, what I did was, this is 45. What I did was I called 7 pi over 8 1/2 times 7 pi over 4, making it into this half angle identity. So I'm trying to make it match this formula. So it's going to be, now it's going to be 1 minus over 2, and the cosine of what? 7 pi over 4, is that right? I think we can actually find the cosine of 7 pi over 4. Where is 7 pi over 4? Fourth quadrant, because 8/4 is 2 pi, right? And we want 7/4. What does that make my reference angle? 1/4. So you look up the cosine of your reference angle. Have you done enough to know that they're radical 2/2? You're going to have your trig table. Hopefully that goes on your note card with your identities and everything else, right? How about in this quadrant, however? In this quadrant, what do we have sign-wise? Is it positive, negative? Alphabetical, cosine, sine. I have the cosine, don't I? So it should be positive, which I have it. So let's see how would you like to solve this? I need to get it into a single, you know I won't accept a fraction and a fraction, right? I've told you that numerous times. Do we want to get rid of this division by 2 by multiplying by 2? Or would you rather get a common denominator? Multiply by 2. 2 times 1 is, and when you multiply here, the 2's cancel, leaving you the radical 2. On bottom, 2 times 2 is 4. So this is probably the answer they have. Let me check. I'll get back with you. Okay, it should not be over 2. It should be over the sine. So on the bottom should be the sine of what? 7 pi over 4, which we know the reference angle is pi over 4. Sine and cosine is radical 2/2. But in this quadrant, what is it? Negative. So that's why they had a different answer, was I did not have the denominator correctly. So how do you want to do this? You have 1 minus radical 2/2, and what are they both divided by? A negative radical 2/2. Does that sound right? So how do you do 1 over something does what? Flips it over, I believe. And what's anything divided by itself? 1. So they call this 1 minus radical 2. The 1 goes first, and if you rationalize this, you're not allowed to leave radicals in the denominator until you hit calculus. So what do you have? Radical 2/2, which simplifies to radical 2. Sorry about that. I had the bottom wrong. Okay, this one we had to rewrite as powers of 1. So I took x to the sine to the 4th, and I called it sine squared times sine squared. Then I used an identity for each of the sine squareds. Then I factored out 6/4 out here, and that times itself means it's squared. 6/4 simplifies to 3/2. I squared the binomial. I squared the first, twice the product, squared the last. Then I distributed the 3/2. And finally, I replaced cosine squared with this. And I combined all like terms to get to the final answer.